In this video, we'll be looking into WAEC 2025 Chemistry Practical for Alternative B. So this is the titration aspect, and this is my powerful predicted question that might come out for you. You understand? So now let's go into this and let's explain this thing better. Well, you can just read this. Say D is a solution containing 0.1 mole per dm cube of HCl. E is a solution containing 3 gram of 3 gram in 500 cm cube of XOH. Then you have to put D in the burette and titrate it with 25 cm cube portion of E using methyl urate as an indicator. So you have to repeat the titration to obtain concordant titer value. Tabulate your reading. Then after the tabulation and calculate the average volume of D used. The equation of the reaction is this you are given. So from the B, you are now asked to calculate the from your result and the information provided above, calculate the concentration of D in gram per dm cube, concentration of E in mole per dm cube, the molar mass of XOH, and the relative atomic mass of X. So that's the question. Now, when I carried out this experiment, then I was able to come up with this titer value. Now look at this. Please take note that this titer value is just a rough titer value. Like my own personal titer value is this. And mind you, I said this question is just a likely powerful question. Like they are just my own predicted question. So the question might change during the exam time, but at least the idea of what we have in this video, it will help you in your exam, even if the question change, but at least to look familiar. Because chemistry practical question, it has the same pattern. So the question used to come in the same pattern. So it will help you. Like those that did alternative A, my predicted question came live for them and they were really happy. So you don't know. You can be fortunate that this question can also come live for you. So watch this video to the end. Share this video to your friend. Give us a like thumb. Give us a nice comment. And I wish you best of luck in exam. So let's dive into this. Now, looking at this table, let me explain something to you when carrying out the practical. Firstly, if you know that you don't want to stress yourself in the practical, sorry, carry out the experiment, then you can just, I don't know how the relationship you have with your teacher, so you can just ask your teacher to tell you the titer value he or she got, because she would have done this experiment before. So once you discuss with her or with him and she told you the titer value she got, maybe let's assume she got 38.00 cm cube as our titer value, because that is what she will write to WAEC when filling the teacher's report, and that is what WAEC will use to mark your school. So you need to be very, very, very friendly, and then you should be very good to your chemistry teacher right now. Please take her or him as your best friend. So in case if she has told you your titer value, and let's assume that titer value is 38.00 cm cube, so what you can just do is that you can just permutate this table like this. Can you see this now? So ignore this rough titer. You can put anything here. You can just put this table like this, then just try to manipulate this table like this. So by the time I look for the average titer value for this now, my titration is going to give me around 38 point, let's say 38.03 or 05. It's still okay, because the range from your titer value and our own should be something around plus or minus 0.2. You understand that now? Plus or minus 0.2. So therefore that should be the range. So if you can ask her and she told you, kudos to you like that. But if she doesn't, then you have to carry out the experiment yourself. Now, let me give you a guideline of how you are going to carry out the experiment yourself. So you have your the specimen for this year is this. The specimen for this year, the sample D is the acid, so they call it HCl. While the sample E is sodium hydroxide. So for the alternative B, these are the two solutions we are titrating together. So the setup would be like this. If you set up your apparatus, let's say you set up your Ritter stand. Let me just give a sketch of Ritter stand here. Sorry. So you set up your Ritter stand, then with you attached your what do they call it? Your burette with it. Remember that you're going to pour this acid inside the burette. Take note of that. You pour the acid inside the burette. So after pouring inside the burette, then you will suck your base. This is your base. This is base. This is acid. So therefore you will suck your base using your pipette. Pipette can be 25.00 cm cube or 20.00 cm cube. So therefore, that's the two pipettes you can use. So anyone you use, your teacher will indicate it for you like that in the teacher's report. You understand? And you too, you are going to indicate it too in your calculation too as well. The pipette, the volume of base you use, that is your pipette. So once you suck the pipette, then you are going to release it in your conical flask. Conical flask is something like this. Sorry, I'm not really that good in drawing. So conical flask is something like this. So you will release it. You will release it inside the conical flask. So after releasing inside the conical flask, then you are going to add two drop of indicator. So this type of reaction, which indicator are you going to use? Based on the from the specimen WAEC gave for this alternative B, they gave phenolphthalein and they also give methyl So you don't know which one they are going to use, but this type of reaction is reaction between strong acid and strong base. This is a strong acid, it's very, very strong acid, and this is also a strong base. So, and from the principle of chemistry, by the time you titrate strong acid and strong base, you can use any suitable indicator is what you can use. So far it is strong acid and strong base, you can use anything you want to use. So all indicator works for strong acid and strong base. So basically you can use methyl orange or phenolphthalein because from the specimen the indicator there is methyl orange and phenolphthalein. So any of the indicator you can use. So once you put the two drop inside this, then the color will change. So after that, then you start running your titration. So ensure that you put this conical flask on top of a white tile. White tile. When I say white tile is just like a tiles you are using in your house, but this one is color white. So it's always in the lab as well. This tile is going to help you to easily detect the color of this solution in this conical flask. So in case if the color change, you easily figure out the color on this tile. There will be a reflection from them. The color of the solution here will reflect on this tile, so you easily figure out the color. So once you start running your titration, then you shake. You understand? So always pressing your burette slowly. Then you shake, you shake, you shake, you shake, you shake. Once you shake, then once you observe the color change, then you're going to stop, and that will be your end point. Color change is your end point. So it's your end point. You will now read the volume of your burette. Burette is in a menu, is in a graduating scale. Yeah, it's in a graduating scale. So you will now read the volume of your burette, then you write it there, and ensure to put it in two decimal places. So it's 0.0000. So put in decimal places. Then after you are done with the first one, pour the whole solution away inside the basin, then pour it out, then rinse this guy like this guy. You are going to pour this one for this conical flask away. So rinse it with with distilled water inside a wash bottle. A wash bottle is something like this. I think it will have one kind straw like this. Sorry, I'm not good in drawing. It will have one kind straw, something like looks like a straw. So that's what we call wash bottle. So water will be here. Distilled water will be inside this place. So once you press it, the water will come out from this place. So once you do that, then you use it to rinse this thing, then pour it out. Then later measure another 25 cm cube of this sodium hydroxide, pour it inside here. So once you do that, so repeat the whole process. I believe that you should have done this thing before in your school, like at least during your SS2, SS3, before the commencement of this WAEC. Your teacher should have at least given you an insight of what this thing is all about. So now this is how I got my table. So after having this table now, so let's now go to the real calculation. So now from here now, please observe this table very well, because I'm going to turn to this particular page. So I have this my theta value. You can see that this one is very far from others, so, and it's even rough theta, so don't use it. So let's now go to the question now. I will be solving the solution here, as you can see. So let me write my solution here. Okay, so now let's go with, say D is an acid. You understand? Because from the specimen they gave to teachers, it is D that is there as the sample, which is the sodium, which is the HCl. D is there, and the E is the what do they call it? E is a base. So this is a solution containing 0.1 cm cube, 0.1 mole per dm cube of HCl, while E is a solution containing 3 gram in 500 cm cube of XOH. but we know that this X represents sodium. You understand? Sodium, the specimen released to teachers, it has shown us that this XOH is sodium hydroxide, okay, and not calcium hydroxide. Take note, not calcium hydroxide, no magnesium hydroxide, it is sodium hydroxide. Okay, so put D inside the burette, fine, we have done that, and titrate it against 25 cm portion of E. Okay, sometimes it can be 22. The instruction in your question will tell you that. And E, okay, portion of E using methyl orange as an indicator. That means the specimen we are asked to use, the indicator we are asked to use here is methyl orange, okay, as indicator. So repeat the titration to obtain a concordant titer value. Concordant means like something that goes like similar, like close ahead. Let me use that word close. Concordant titer value. Tabulate your result and calculate the average volume of acid used. So the first thing to do here is to calculate the average volume of acid used. Average volume of acid use. So from here now I have, okay, so from here now I have my first, second, and third. So let me come here and say my first title. Let me just write second title and then the third title. So everything all over 3. So that will now be 38.10 plus 38.00 plus 38.00. So by the time I find the average using my calculator, so 38 point plus 38 plus 38.10. So that will give me 114.10 all over 3, and that will be equals to 38.03 cm cube. Ensure to put the cm cube there. Okay, so please, and then also, hey, lest I forget, please, when you are writing this thing, always put your centimeter cube here. It's very important. Is that how you put it here or you put it here? Any one of the two you want to use is okay with that. Okay, so now I find the average. Okay, where is it? Repeat the, okay, I've calculated the average volume of D used, so that's it. Now the equation of the reaction is this. You can see that. Now from your results and the information provided above, calculate the concentration of D in gram per dm cube. So imagine that D is the acid, don't forget. So now from the B now, so from the B says I should calculate the concentration, BI, I should calculate the concentration of D in gram per dm cube. So the formula I will use for this is concentration of D in mole per dm cube, in mole per dm cube is equals to concentration of D in gram per dm cube. So all over what? Molar mass. So that was the best formula for me to use. Okay, so now let's look at this now. From here, from this question now, we are given D is a solution containing 0.10 mole per dm cube of HCl. Imagine that this thing is what? Concentration of D. D is HCl in mole per dm cube. So I know my concentration of D in mole per dm cube is 0.1. So let me just come here. Okay, I'm looking for in gram per dm cube, right? So I can cross multiply. I can put over 1 here. Get the gist now. So let me cross multiply. That will be concentration of D in gram per dm cube equals to concentration of D in mole per dm cube all over the molar mass. Okay, so now you can see, okay, oh sorry, times, that will be times because I am cross multiplying. So sorry about this, let me wrong this. This is times, it's going to be times. Imagine this one times 1, this times this. So that will be concentration of this in mole per dm cube. So times molar mass. It's times, take notes. Times molar mass. So now concentration of D mole per dm cube is 0.1 from the question here. And what is the molar mass of D? Molar mass of HCl. Please, the molar mass of HCl, you must show it here. Don't just assume that Shebi H is HCl. H is 1 and HCl is 35.5. Show the workings here because it will attract mark. You understand? So that will be 36.5 gram per mole. That's the unit for molar mass. So it's 0.1 times 36.5. So by the time I do the calculation from here, So it's 0.1 times 36.5, and that gives me 3.65 gram. So that will give me 3.65 gram per dm cube. So that gives me 3.65 gram per dm cube. Okay, so I think I've done the first one. So I've done this. So the next one here now is that concentration of E in mole per dm cube. Okay, so that will be the II. So concentration of E is the base, so don't forget concentration of E in mole per dm cube. Definitely, the next thing for you to do is to use your CAVA equals to CBVB. Yeah, that's the next thing. So CAVA, because in mole per dm cube now, if you look at this place, if you look at this place says that you have to look for concentration of E in what? In mole per dm cube. Normally, two ideas will come to students' mind whenever they come to this particular number BII. Now, the first idea that may come to your mind is that since we have our E here, it says a solution containing 3 gram in 500 cm cube. Let me show you one thing first. Please, let me just take a rough book here to show you something first here. I want to show you one rough calculation here. It's not correct, but just learn from it. So, if you have to calculate the concentration of E in mole per dm cube here like this now, an idea can come to you by saying that since I have my E is in 3 gram, since E is 3 gram in 500 cm cube, so student can say concentration of E in gram per dm cube is equals to, gram is mass, dm cube is volume, and equals to 3 gram divided by 500 over 1000 dm cube. Did you see this estimate? Did you see this calculation? Now look at it very well. This is 3 gram over this. Like I converted this cm cube to what? To dm cube. So that will now be 3 gram over, this will be 0.2. Yeah, let me check. 500 divided by 1000. That's 0.2. Let me confirm it is 0.2. Okay, 500 divided by 1000. Sorry, 0.5. 0.5. So it's 0.5 dm cube. So therefore, once they now divide this, that will now be 3 divided by 0.5. That will be 6, right? Okay, that's 6. So that's 6. So that will now be 6 gram per dm cube. 6.0 gram per dm cube. So that's concentration of E in gram per dm cube. Remember that this question says that we should calculate the concentration of E in mole per dm cube. But from here now, I've gotten E in gram per dm cube. So I can now actually use this formula to calculate the concentration of E, like this formula of E in mole per dm cube, according to the question I have here. Concentration of E in mole per what? Per dm cube. So I can use this formula to also work it out the way I did this one. Concentration of E in mole per dm cube. Use this method. But what will make me not to use this procedure, this process is that if you look at this place now, I can be able to calculate the molar mass of HCl, which is at 6.5. But from this particular question now, there is no way I can calculate this molar mass because I don't know what X is. I don't know what is X. So I cannot calculate the molar mass of this. So that is what is going to make me not to use this method to solve this particular question BII. Hope you understand. I only show you this rough idea for you to at least to learn, should in case if you come across it in chemistry or in your exam or anything. So now let me now follow the normal process now. So the normal process, the only method I can use is to use my C that will now be CDVD over what? CEVE equals to ND over NE. Take note of that though. Don't go and be using CAVA equals to CBVBO because things has changed now. Those that did alternative A they are the one that will be using CAVA equals to CVVB. Your own must be CDVD equals to CEVE. So don't make that mistake. So I'm asked to look for CE. What I'm looking for is CE. I know my ND is 1:1. You get 1:1 from here. The mole ratio of HCl is 1 here. The mole ratio of this guy is also 1. So then I have it as 1:1. So my CD is I've calculated it before. I was given my CD. Now that's what 0.1 mole per dm cube. So let me make CE the separator formula. So CE will be equals to CdVd times Ne all over VE times ND. So my CD is now 0.1 times VD. That's the volume of the acid. My volume of the acid from this now this is it. Yeah, my volume of the acid, that's 38.03. So 38.03. So multiplied by Ne is 1, right? All over my VE, the volume of the base. Okay, that's 25.00 times 1. So now I have the whole. Now let me do the calculation. So this will now be 0.1 times 0.1 times 38.03 times 1 divided by 25.00. So that gives me 0.152. Please put it in 3 significant figure. 0.152 mole per dm cube. Correct. 0.152 mole per dm cube. So that is the concentration of E, that is the base, in mole per dm cube. Okay, so I've answered this question now. Now the next thing to do is now the molar mass of what? The molar mass of XOH. You get it now? Now, if you want to use the molar mass of XOH now, look at this. So please, you can see chemistry question in practical, like chemistry practical question, each question used to help each other. This question help this. The answer you got here will help this one. The answer you got here will be used to calculate this one. I am very sure that anything you got here will be used to calculate this one. So once you make any mistake here, my dear, everything here is 0. You know what I'm saying now? Once you make any mistake here in this first one, everything here is 0. So now, how are we going to calculate this one? This I now. The formula we are going to use is this formula. This particular formula here. Let me use my red pen to indicate it. Is this particular formula here we are going to use? This formula. So is this formula. You get it now? So if you are using this formula to calculate this molar mass of XOH now. So molar mass of XOH. This will now be molar mass of XOH by the time you do the cross multiplication. So molar mass of XOH will now be concentration of E. You know, XOH is E. Remember, that's the base. So that will now be concentration of E all over in gram per dm cube all over concentration of D in mole per dm cube. Okay, let me write it here. So I. So molar mass of XOH. Please share this video to others. At least it will help them in one way or the other. At least it will give them an idea of what they are going to do in their exam next week. So concentration of D in gram per dm cube. So that will be concentration of E, rather is E in gram per dm cube all over concentration of E in mole per dm cube. You understand that now? So what is the condition of E in gram per dm cube of this guy? Which guy? Sodium hydroxide. It is this thing I worked here. It is this particular thing I worked here. This is the answer here. This is the 6 gram. You can see that anything they give you in chemistry practical question, you will surely use it for in one way or the other. So they know what they are doing. You can see anything they give you in their question, you will surely use it in one way or the other. They know what they are doing. So this is going to be 6 gram all over what? So this will be 6 gram per dm cube all over concentration of E in mole per dm cube. That is what we got here in mole per dm, and that's what is 0.152. So this is 0.152 mole per dm cube. So by the time you divide this, let me use calculator here. So that will be 6 divided by 0.152, and that will give me 39.47, or okay, 39.47. The unit will now be gram per mole. Okay, so now after doing that, so what is the next thing? I've answered this question like this. Now I've answered this. So the last question is now the relative atomic mass of X. It is this answer you will now use to get that one. That will be IV. So relative atomic mass of X, is XOH. So the molar mass of this XOH is what? 39 point, let's say 39.5. Let me approximate. 39.5 gram per mole. So therefore, this X now, you don't know what X is. Let me write X plus what is O 16, what is HI, equals to 39.5. So by the time you now say X is equals to 39.5 minus 17. So your X will now be equals to let's see, 39.5 minus 17, and that will be 22.5. So 22.5, X is 22.5, approximately 23. Can you say approximately 23? I remember that sodium. What is the relative atomic mass of sodium? 23. So that's sodium. As you can see, that's sodium. So please look at this question very well. It is question that you should not take with levity and please take it serious. So sodium is 23. So meaning that the X represents what? 23, which is sodium. So that's how the question goes. Please share this video, I beg. Please share it to your friends, share it to everybody, let them learn. At least it will not even it will really help them. And give me a like thumb. If you wish, give me a super thanks. It's on my channel. You can see there. Give me a super thanks. I think it's going to require you to pay some money to YouTube. So from there, they can now at least credit me 1 or 2. So give me super thanks. Share my video to your classmates, your friends, and everybody, teachers, parents who want the student to learn. And also give me a nice comment. Thank you so much. And I'll be working on the part B. That's for the SWOT analysis in my next video. So if you also need the part B, just comment that you want part B. Comment part B, and I will send you the link for the part B. That is for the SWOT analysis. And the SWOT is, don't worry, I will tell you in the part B. Thank you so much. Bye.